Okay, Assalamualaikum and good morning, everyone. I'm Dr. Nuraza Abu Bakar. So, I'm going to continue your class with the mesh analysis. So, before this, you already covered about the KVL, Ohm's law, and also the nodal analysis. So, on my part, I'm going to continue with you guys about the mesh analysis, DC and AC. And also, we are going to look in terms of the Thevenin theorems and superpositions and so on. Okay, so for today, I'm going to conduct this very short lecture. So just about around, I think about 10 minutes just to give you some fundamental views. And then after that, hopefully you guys can do some of the exercise, which is as I'm sharing before, okay, in the slide. So now for the first part, we are going to look what we mean by mesh analysis, okay? So now let's say if we have this kind of circuit, okay, sorry, okay, we just look a very simple circuit here. Let's say we have a very common circuit here, which is we have sorry, maybe I just put another one. Okay, so let's say we have a V1 here, V2 here, we have R1, R2, R3, and also R4. Okay, so before this, you already learned about how to solve this problem either by using the you can use KVL, KCL. Some of you may use some of the what you have learned before, nodal analysis. Okay. Now, which is if you can recall that what you have done before by using nodal analysis, you are looking for the nodes. Okay. So the nodes, and then after that, you are going to implement in terms of the KCL, okay, to find the voltage, voltage at the nodes. It could be V1, V2, and so on. Now, under mesh analysis, okay, mesh analysis, we are going to find how many loops in the circuit. So, for example, in this case, so we have this is one loop, okay, it close from here to here, and we have another one loop here. Okay. So it means in this example, we have two loop. Now, normally we are going to call this as I1 and also I2. And in terms of the directions of the current, so it's up to you. You can use clockwise or anti-clockwise, but of course we try to standardize in terms of our lecture. So I'm going to use in terms of the clockwise. Okay. So now for mesh analysis, we are going to use, instead of KCL, we are going to use KVL to obtain the I1 and also I2. Now let's we going back to this circuit here. Now let's say if we try to find let's say we put, okay, so this is IS. So how to find IS here? So for mesh analysis, we have here we have loop 1 and also loop 2. So now let's we just consider about loop 1 first. Okay, loop 1. Now what happened at loop 1? So if we implement in terms of the what we call if we try to implement the KVL, let's say we begin from here. So it's begin minus V1 plus, so this is I1, sorry, this is I1, right? Okay, so which is we are going to set, okay, plus I1 R1, and when it's come here, so we have at this junction, it's supposed to be in terms of the I1 minus I2, right? So it could be renamed as the IX. Okay, so which is we have a plus I1 minus I2 times with the other 3, and it close here, no, so everything here is going to be equal 0. So if we rearrange this equation, so it's become, so I1 is going to be R1 plus R3 minus I2 times R3 equal V1. So this is going to be equation number 1. Now let's say we focus on the loop number 2. So what happened at loop number 2 here? Okay, so again, we do the KVL here. Now let's say we begin from this point. Okay, so it's going to be I2 R2, okay, come to this point plus I2 R4, and it's made positive, negative, so it means it's going to be positive V2, and come to this point, so which is we meet another here, one here, so which is because its difference is going to be minus IX, so we can write here as plus I2 minus I1 in bracket R3 equals 0. Now, if we try to rearrange this circuit, so what we can write here is about the minus I1 times R3 plus I2 is going to be R2, 3 and 4, R2 plus R3 plus R4 equal. So when we transform from this voltage from here to here, it's going to be minus V2. So we're going to have equations V2 here, right? So, and then after that, of course, to obtain the value uh, IS here, so if we look here, so it's mean IS is the same direction like I1, so we can say IS is equal to I1 is number 3. Now we have equation 1. So this is equation number 1, equation number 2, and equation number 3. Okay, so to obtain here, so you can use the determinant concept, or also you can use the long constitute to obtain the value of I1 and also I2. Okay, so this is one example. Okay, now let's we look I just up to here I just come to the equation. So let's say if you try to solve the problem, so you can use in terms of the determinant concept. So which is it's going to be, let's say this is I1, this is I2. So what you can write here is so I1 here is minus I1 here is R1 plus R3, and then I2 here is from equation 1 is minus R3, and also we have here is row number 2 minus R3, and the plus here is going to be everything here R2 plus R3 plus R4. Okay, and divide by and you're going to do determinant here, okay, for the first round, and then after that to obtain the I1, so it's going to be determinant 1 divided by determinant. What is determinant 1? Determinant 1 is we replace the value of I1 with V. Okay, so this is how to use determinant. I'm not going to share how to solve this at the moment, so you can find the lecture. No, I'm just going to share the concept of mesh analysis first, and try to solve the problem that I'm sharing with you guys in lecture notes. And then after that, we look what you can do later. Okay, now let's have another example here. Yeah, I'm going to, sorry. Okay, so let's sorry. Need to find here. Okay, never mind. So let's we just erase everything here first. Okay. Okay. Yeah, I think just delete this. Okay. Now let's we go for another examples here. So now let's we have this kind of circuit, and now we have the power in between. Okay, and we have this kind of circuit here. Okay, right. Of course, you can solve the problems either by using mesh analysis or you can use KVL, so on. So it's up to you. So now let's say if our task is to find what is the value of uh, I2 here. Okay, so again, back to basic concept. So the first step for mesh analysis, now we need to find how many loops that we have here. Of course, this is one loop. So we have another loop here, two loop. So I name this as I1, I name this as I2. So this I put I2 prime. Okay. So it's mean in this, so we can say that, okay, so I2 prime, it just equal to I2. Now, if we try to find I2, so what we need to do, so we are going to consider what happened at loop number 1 first. So which is, let's we begin from this point. So it's going to be I1 R1 plus I2 R2. Okay, right? And then after that, plus with the Vs equal 0. So this is going to be equation number 1. So now we have a loop number 2. So we have here, let's say if we begin from this point, so we are going to have a minus Vs plus I2 R3 plus with the R2 R4 and equal 0. So if we rearrange, so this is equation number 2. So if we rearrange everything here, so we're going to have two kind of equation. But of course, so what is the difference this time? So we are going to find that, okay, so although we know the current flow here, but because since we only have the purely voltage source in between the loops, so it's not what we call we don't have to find what is the value here. Okay, so that's why we don't have the case which is I1 minus I2. So what we have in our equation is totally separate. So we have I1, we have I2, and then I2 again. So this is everything is I2. Now, of course, it's very straightforward. Now, let's say if we have a case where is the in between, we have this kind of circuit here. So we have like this, okay, but we have plus minus, and again, it's quite the same thing. Okay, and this one, we just, okay, so now this Vs, this is R1, R2, R3, R4, and R5. Now, what is the difference between now and previous? Of course, we have the additional resistance here. So which is, now let's say if we try to consider how many loops here, again, just the same thing, loop 1 and loop 2. Okay, of course, when we implement in terms of the loop 1 here, so we are going to have what we have here. So if we do the KVL, so it's going to be I1 R1 plus I1 R2, sorry, 1 R2. Now we need to consider in terms what happened at I3. So since we follow the directions of I1, so I1 is going to be positive here. I1 minus I here, let's say I put Ix. So Ix is going to be I1 minus I2, right? So we're going to write I1 minus I2, R3, and then of course we close here plus Vs, and everything here is equal to 0. So if we rearrange all of these equations, then we're going to find that, okay, so I1 is equal to R1 plus R2 plus R3 minus I2 R3 equal this plus, bring to the other side is going to be minus ds. Now this is our first equation. So now when we consider in terms of the loop number 2, what happened here? So the direction here is going to be minus ix. What is minus ix? Minus ix is equal to I2 minus I1, right? Okay, now let's reconsider this loop. We begin from here. So negative, so minus Vs a plus I2 minus I1 R3 plus we have R4 and R5. So I2 R4 plus I2 R5 equal 0. And we rearrange this equation, then we're going to obtain I1, sorry, okay, R3 plus I2 R3 plus R4 plus R5 equal, we bring this to the other side, it become positive. So now we have equation 1 and equation 2, right? So of course, again, so we can solve the problems either by using the determinant concepts, or we can use in terms of long substitutions. Okay, so I think that's it for today. So so what I want you to do later on is you try to solve the problems that is already shared in the what you call in the WhatsApp groups. Okay, try to solve this problem first, and then after that we are going to discuss in our next lecture. Okay, but of course in the same time also try to learn what happen if we have instead of we have the voltage source. Now what happen if we have the current source in the circuit? Okay, I think that's all. That's it for today. And see you again next week on Monday. So I'm going to inform to you via our WhatsApp groups. Yeah, Assalamualaikum warahmatullahi wabarakatuh.